Hey there.
All right, finishing up with continuous graph and discrete graphs.
So 4.4 part 2.
Yeah, I know.
Okay. All right, so here we go.
Pretty easy. Continuous graph means it continues, so it's not broken. Or
And
here it says unbroken.
And a discrete graph is composed of distinct isolated points. So I can think of if I'm selling t-shirts, I would not, when I'm plotting t-shirts sold and amount, it's going to be
a discrete
graph because I can't sell a half of a shirt or a third of a shirt, or there's not a relationship between all of the shirts. It's just single parts.
Right. But if I'm selling, well, shoot, now I can't think of a continuous.
Well, if you're riding your bike to school.
Okay, sure. Even if you stop, it would be a plateau like we've talked about.
Right, because time continues. You can plot, anyway, partial time.
There you go.
Okay, so.
Now we're going to look at a real world problem with this. So we are looking at cheese. Everyone loves it.
I love cheese.
I know.
Okay, so a local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation, graph each function, and then decide, is it continuous or discrete? So we're going to look at two different situations. We're going to look at the milk and the amount of cheese in ounces that we can make. And then we're going to also look at selling the wheels of cheese for cost. Okay.
So you're telling me that this guy he sells wheels of cheese?
Yes.
No partial wheels?
No, he only sells a full wheel.
Got it. Okay. So here it says the weight W of cheese in ounces depends on the number of gallons of milk used. So W equals 16 M, meaning weight equals 16 milk.
16 milk.
Well, that's what M is milk. I don't know how to word that. 16 gallons of milk. There we go. Yowza.
Well, and it said to write a function, but we already have the function written for us.
Right. There it is.
So, again, we would get that by seeing the rate of change of 16 each time.
And then they just continue to graph there. So you always start with 0, 0 in a real world. So if I have 1 here, that would give me 16 ounces of milk.
Cool.
And so on and so forth.
Okay.
Over here.
Over here we've got the wheels. Again, if I have 0 number of wheels, I'm going to have $0 that I make. But it's represented by A equals 9M. So then if I look at the table, if I have 1 number of wheels, I would have $9 as my amount that I make.
And then you just continue the pattern here.
Cool. Okay. I think they got it.
Okay. Now we're just going to graph that.
Okay. So
there we go.
We're going to plot. We'll do weight of cheese and milk first. So 0, 0. Oh, you're going to number it. Probably a good idea.
So I'm just going to skip. So I'm going up by 0.5s, but I'm actually, you only see those.
Good idea to spread it out so you can actually see what's happening in the graph.
Okay, what do you think I should go by here? Because I need to go up to 64.
Well, how many lines do we have?
1, 2, 3, 4, 5, 6, 7, 8, 9.
10. Because the top would be 10, right?
Yeah.
Why don't we go by tens?
Sure.
Okay.
So 20, 40, 60, 80.
Cool.
100.
Okay.
Again, notice how it's labeled. Weight, ounces, milk, gallons. Okay.
So 0, 0.
We'll
oh, my tools are gone. Sorry.
It's all right. And then 1 up to 16. Wow, that didn't work for me. 2 up to 32. So about here. 3 up to 48. And over to 4 and up to 64. Okay.
Okay.
Now let's go over here. We'll plot that first, and then we'll discuss.
Yeah.
So I start with 0, and then we go by the same range down here. So skipping 1, going up by a half. Going up to 36. Do you think I should make my intervals the same, or should I widen my intervals?
Let's widen it out.
Okay, so maybe go up by 10s? Go up by 5s, excuse me.
Sure. Yeah, because we only have to go to 36.
Right. Okay. All right, so 0, 0.
0, 0.
Easy.
1, 9.
9. 2, 18.
Yeah. 3 to 27, almost to 30.
Okay.
And then 4, 36.
Right there.
All right. So now we need to decide, are we going to connect or not?
Okay.
So on the left side, I believe that I can have
This is weight of cheese, money earned.
Okay, so on the left side, I could have partial amounts of ounces and partial amounts of gallons, right?
I think so, yeah. That makes sense to me because you can have 0.5 gallons of milk and that would give us a certain amount of.
Well, okay, so 1 gallon gives me 16 ounces. So I'm assuming that 8 ounces would give, I'm sorry, a half of a gallon would give me 8 ounces of cheese, right?
And then if I plot that,
It would be right there.
Yeah.
So there are amounts.
So you're saying this one would be my.
You're continuous.
Okay.
There are values in between each dot.
Yep.
Now, on the other side, so that's continuous.
Okay.
So then on this side, this is wheels sold, okay? And we know that this guy does not sell partial wheels.
Right.
So he's going to sell 1 wheel. He's going to get $9.
Okay.
He's
so
not.
Can I do half?
No, he's not selling a half of a wheel. He's only selling wheels. So this is a discrete. And so we just leave the dots alone.
There you go.
Cool.
No, should have used a straight edge here.
Yeah, sorry, our tools went away.
And we know that you can argue that some places sell half wheels of cheese. This guy doesn't. He's the boss here. Okay.
All right. So again,
graphing.
Another graphing situation. Notice how we're bringing it back to absolute value. So we're spiraling back to some of those other concepts.
Okay. And what were these that you liked that you said that we should always use?
Wasn't it -2, -1, 0, 1, 2?
I like those.
I like those.
Okay. So we're still doing the exact same thing. Just this time it has an absolute value symbol.
Okay. So plug in my absolute value in there. So absolute value of -2. Actually, they use 4 in the book.
I don't know why that is.
Okay.
So what's the absolute value of -2?
2.
+2 minus 4
is 2.
So my first order pair is -2, 2.
Mm-hmm.
Okay. Absolute value, -1
minus 4.
So it's a +1 because absolute value is always positive.
So 1 minus 4 is -3. So -1, -3.
Okay.
I'm kind of seeing a pattern. 0 minus 4 is -4. So 0, -4.
Okay. Absolute value of 1
is 1.
minus 4. So like she said, it's 1 minus 4. So then that would be 1, -3.
Now it's going a different direction.
Yeah, I've already used -3.
Well, that's okay.
Are you sure?
I think it's totally fine.
Okay.
I mean, it's what is shown.
Okay, so here I have a question, Richardson.
Mm-hmm.
The absolute value, you said the absolute value of 1 is 1. Is it not -1?
No, it's always distance from 0, and it's always positive.
Remember that. I know this. Okay.
2 minus 4 is -2. So 2, -2.
Oh, 2, -2.
Mm-hmm.
Okay.
Okay, so then if we're going to put
plot
this on
these.
a graph, we will have -2, 2. So start at origin, go over -2, up to 2. Then we're going to have -1, 3. So over -1, oh, -3.
Oh.
Is it -3? Your top one should be -2.
Oh, it
Shouldn't it?
should be.
Yeah.
2 minus 4.
Is -2. And then,
Sorry.
Okay.
Sorry.
Well, that was an easy fix. You didn't have to erase anything. There you go.
There we go.
And then -1, 3, -3, sorry. 0, -4.
Oh, it's linear.
So far, yeah. Then 1, -3.
Oh, so I should keep plotting all of them.
Mm-hmm. And then 2, -2. Okay. And then we connect the dots.
With a straight edge. I apologize that we don't have it. Arrows on the end. Take up that whole graph. That's a funny looking graph.
Mm-hmm. Do we need to? No, we don't. We're good.
So this is absolute value. So one thing you want to remember is if you have ABS.
Absolute value. It's going to make a V, right?
So the V tells you what it's going to be.
Mm-hmm.
Absolute value, V.
It's going to make a V graph.
Yep.
Cool. Okay.
Let's do it again.
Okay, this one is squared.
Okay.
It's not absolute value, but I'm guessing it's going to make a different shape than a straight line.
So we'll just write squared up here.
So that other one, it was a function because each input had exactly one output.
Correct.
But it was not linear.
It was not a linear function.
No.
Right,
Okay.
but it was a function.
Okay, so this is also a function, but it may or may not be linear.
Right.
So -2, 1, 0, 2.
Okay.
Plop those in there. And why don't we, for the sake of time, fill in the chart for them.
Well, they're going to have to write this down themselves,
I know.
right?
Yeah, you should write it down. Oh, that's fine. Okay. So all we're doing is plugging in the x value for the value of x in the equation,
Mm-hmm.
and then we'll solve. So -2 squared,
So it's -2 times -2.
so that's
So
positive
that's 4
4
plus
plus
1
1.
is,
So -2,
geez.
5.
Okay,
Next one is -1 times -1 is 1.
positive 1.
So, and then plus 1 is 2. 0 squared is 0, plus 1 is 1. So we have 0, 1.
Okay,
And again, that the first number is coming from our x column there.
correct.
Okay, next one, 1 times 1 is 1.
Okay,
Plus 1 is
2.
2. And
Two
then we have
times two?
2 times 2 is 4,
Mm-hmm.
plus 1 is 5.
2, 5. Those are very similar.
It
Okay.
is very similar.
So let's plot these. So -2, 5, so start the origin. Left 2, up 5.
5.
Okay,
-1, 2. That's a little different.
it is different.
The 0, 1. Oh. 1, 2. And then 2, 5. Over 2, up 5.
5.
Okay, so it kind of looks like a V, but
Kind of.
those are scrunched together. That's going to make a U shape. I love it.
And so, there's our U in the word
In the
squared.
word squared. So if
Pretty
there's,
cool.
yeah. Okay.
We've
So-
already done one.
Mm-hmm.
You do too.
So you're going to, and you should have, do they have a graph on
Mhm.
there? Okay.
Yep.
So check this out and then decide, is it continuous or discrete? And we should see either connected dots or not.
You got it.
We'll see you on the flip side.
Later.